Hi, and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. Last time we met, we subset our data file to the state of California and kept only male and female respondents. We also made a hypothesis that California girls would have better health than California boys. In the next 3 videos, we're going to be working on some prevalence estimates. So first we'll do data cleaning, then data analysis, and wrap it up with some data visualization. Today, we're going to read the article that we're going to base our analysis off of, subset our data file again, and then clean our data. The article that we're mimicking our analysis on is the CDC report called The Surveillance for Certain Health Behaviors and Conditions Among States and Selected Local Areas, BRFSS US 2015. So let's first start by tracking down our article. So search for CDC BRFSS, click on the first result, CDC BRFSS, scroll down just a little bit to Publications and Resources. On the left side, under Publications and Resources, click on Surveillance Summaries. And the CDC has published a surveillance summary every year since 2003 on BRFSS data as far back as 2001. So these reports give a really comprehensive, thorough description of the health statistics from that year across a huge range of geographic areas. So we'll be working with the most recent surveillance summary, published in 2018 on data from 2015. So let's download the issue, open it up. All right, and this is it. It's an article. It's a large article. It has 96 pages. Most of those are data tables. So the first 16 or 17 pages is the article, but then the rest are the data tables. So the rest of this document are all tables. And what the CDC did for this surveillance summary is they looked at unweighted sample size, weighted prevalence estimate, the standard error, and the 95% confidence intervals. And they looked across a ton of different states and territories, a really large geographic region. And if I counted correctly, they looked at 19 different health variables. So let's jump up to the statistical analysis section, which is oh, my mouse is so slow. Let's see. Here we go, statistical analyses. So, okay, one thing important I wanted to mention is that in this report, they applied an age adjustment because they looked at different populations across states. And if you were comparing populations over time, you may also use an age adjustment. For our analysis and these tutorials, we won't be applying age adjustment because I want to keep it simple. And we're only looking at California in 1 year. So we're not looking between states or over time. And it's not that crazy that we're not applying age adjustment because if you scroll over to the next column, you'll see here that before 2012, the CDC didn't even apply age adjustment for these reports. So we're not doing something crazy. We're just trying to keep it simple. As you know, the CDC provides great resources for SAS. So they used SAS and SAS Callable Sudan to analyze these data. We're using R. All right. And just to reiterate what they did for this report, they looked at the unweighted sample sizes, weighted prevalence estimates with the standard error, and the 95% confidence intervals. They looked across all of these different health indicators, and I counted 19. So this is a great report. It's very thorough. It's comprehensive. What I wish they would have done is told the reader what health variables from the BRFSS survey are described in this report as health indicators. So when I say health indicators, I'm talking about the health outcomes described in the surveillance summary. When I say health variables, I'm talking about the name of the question in the BRFSS survey. Okay, so I counted 19 health indicators. They did not tell us the health variables or the questions from the BRFSS survey. So I did my best to try to match those up. which I've outlined here in this table. So they looked at adults having good or better health, more than 14 days of poor physical health in the last 30 days, more than 14 days of poor mental health in the last 30 days, people with healthcare coverage, people who have had a routine checkup in the last 12 months, have ever had their blood cholesterol checked, current smokers, binge drinking in the last 30 days, no leisure physical activity in the last 30 days, fruit intake less than once per day, vegetable intake less than once per day, people who have obesity, diabetes, arthritis, depressive disorder, high blood pressure, high blood cholesterol, have had coronary heart disease, and have had a stroke. All right, so that's 19. I did my best to try to match up the variables with the health indicators, and those are listed here. Let me take you to the codebook so we can just take a look at a few of those. So we go back to the CDC website, survey data and documentation, annual survey data, 2017 data, 2017 BRFSS codebook. All right, so one of the health variables that they looked at was called RF health. And that is adults with good or better health. So their calculations are based on this first value of people with good or better health. So that's what they looked at, value 1. So that's what the prevalence estimate is for value 1. However, another variable they looked at was RF smoke 3, which are adults who are current smokers. So the value that they calculated their prevalence estimates and everything else on is this value 2. So what we need to do in order to make our analysis easier is look at the health indicators that are reported in the surveillance summary and match it up with the health variables in the BRFSS codebook and then recode these values so that 1 means yes, this is what they measured in the surveillance summary, and 0 are all of the other responses from that question. So, for example, for RF smoke 3, we'll recode 2 to 1 and 1 and 9 to 0. For RF health, we will recode 1 to 1 or just keep 1 as 1 and recode 2 and 9 to 0. All right, and we have to do that for every health variable. So I already went through and figured out which value we need to recode to 1. So for example, for RF health, we have to recode 1 to 1. For Phys 14D, we have to recode 3 to 1, so on and so forth. All right, for this one, have you had your blood cholesterol checked? The way the question is written is response answer value 1 is never, and values 2, 3, 4, and 5 are all yes, but on a different time frame. So we want yes, so we recode 2, 3, 4, and 5 to 1, and everything else as 0. All right? Something else which you may have noticed previously, but I haven't said explicitly, is as I'm typing variables into the R console, if there is a variable with an underscore, we have to put an X in front of it. So, for example, in the codebook, RF health, the variable does not have an X in front of it. It's just underscore RF health. But R doesn't like it when objects or variables or anything starts with something beside the letter. So it goes ahead and puts an X in front of it. All right, so when you see underscore RF health, that is the same as X underscore RF health. All right, so I've talked enough. Let's go to R and start by setting our CRAN mirror, of course, to the cloud, set our directory, to desktop R for BRFSS. We'll be using the Rio package today, so let's call it out of the library, as well as the tidyverse. And now what we want to do is load our subset data file from last time. So that was called California Girls 17. So read.csv, quote, California Girls 17.csv, end quote, comma, header equals true. Let's check the structure of that just to make sure that we have California Girls 17 to make sure that we called in the right data file. This is our structure. So we retained all 9,355 observations and all 240 variables. So we called in the right thing. That's good. Now what we want to do today is subset that California Girls 17 data file to include only these variables that are described in the surveillance summary report. So we just want these 19 health variables. So in order to do that, we have to set an object which we will call keep var for keep variable. You remember last time we did drop var, this time we're using keep var. We set an assignment arrow. Now we're using a function which I use a lot, but for the life of me, it's so hard to remember what it's actually called. It's this, C parentheses parentheses. And this C stands for a word that I cannot pronounce unless I'm looking at it. Concatenate. Is that right? Concatenate. So I never use that word. I honestly can't even remember it. So when I type C parentheses parentheses, I just think contains. So we're setting this object, keep var, to a list of variables contained in this C parentheses parentheses. And so what we have to do is type out each variable. And I don't want to waste a bunch of time just having you watch me type, so I've already prepared that list here. All right, so here we have our 19 health variables described in the surveillance summary. We are looking at sex differences, so we also have the sex variable. And then these, PSU, LLCP weight, and STSTR, we're not going to use them today, but as I mentioned previously, BRFSS applies a complex weighting design. So we'll use these later when we start working with the survey weights. Okay, so let's copy all of these variables and store them in our keep var object. So here they all are. That's 23 total, 19 health variables, the sex variable, and the 3 weighting variables. All right, so now what we're going to do is make a subset data file, which we will call CG17 for California Girls 17 underscore PE for prevalence estimates. So CG17 underscore PE. Set the assignment arrow, and this data file is actually California Girls 17 bracket. We're keeping all of the rows, but we're just keeping the columns stored in the keep var object. Let's check the structure of CG17 underscore PE. And we can see, yep, we retained all 9,355 of our observations and our 23 variables. So 3 weighting, 1 sex, 19 health. That's great. We're doing really well. But as you remember, I've said so many times, we want R to recognize our variables as factors. So here, it's seeing them as a bunch of integers. Right? So that's one problem. The other problem is that we still have to recode everything. All right, so for sex, we want to recode 1 to be male, so we'll change the 1 to an M. We want 2 to be female, so we'll change the 2 to an F. For our RF health, we want 1s to be 1s, and we want everything else to be 0s. So what we have to do is call the name of our data file, CG17 underscore PE $, and let's start with the sex variable, sex. So assignment arrow. Now we're going to do 2 operations at once. We're going to recode our responses on the sex variable and also set that variable as a factor. So as dot factor, so that's the first command. And then inside of that command, we're going to recode parentheses. Let me make sure I have all the right syntax. Okay, CG17 PE $sex. So recode this column where apostrophe, that's like single quote, apostrophe where 1 equals M and 2 equals F. And if we have any missing data, so dot missing, set that equal to 0. And the default also is 0. And close the parentheses because we have 1, 2, open parentheses. We need 1, 2, close parentheses. So let me just, I have my notes here. Let me make sure I typed that correctly. That looks good to me. Let's test it out. Now let's recheck our structure of CG17_PE. And we did it right. So our sex variable is now a factor with 2 levels having F and M. So if we call CG17_PE $sex, if we call that column out, you see it's all M's and F's, which is exactly what we want. All right. Now we have to do that for the remaining 19 of our health variables. So rather than typing everything out in the R console, I've already done everything in Word. So I'm just going to walk you through what it looks like, and then we're going to copy and paste it in. Because, I can make a mistake by typing and it will take a lot of time. So this is more efficient, I think. So for the RF health variable, we want to set it as a factor and recode 1 to 1 and set everything else, the default and the missing values, to 0. All right. For physical 14 days, we're resetting 3 to 1 and setting the default and the missing values to 0. All right. For men's 14 days, we're setting 3 to 1 and everything else is 0. For this question about healthcare coverage, 1 is 1 and everything else is 0. Okay, and I've done that for all 19 health variables, which we talked about in this table. All right, so these values that we want to recode to 1, that's what I'm talking about here when we say recode something something equals 1. All right, so they're all here. All right, I'll just scroll through so you can spot check it. Checkup, this is the one about blood cholesterol, current smoker, binge drinking, no physical activity, fruit less than once per day, vegetables less than once per day, obesity, diabetes, arthritis, depressive disorder, high blood pressure, high cholesterol, I think, coronary heart disease, cardiovascular disease or something, and stroke. All right, and we see all of these, recode 1 to 1, recode 1 to 1, here 2 to 1, defaults and missing values to 0. Okay, do you see the pattern? Right, so I went through and did these one by one because I wanted to make sure that I was recoding the right values in the codebook to the values that we want to correlate to the health indicators in the surveillance summary. And I will make all of this code available in the description. So for now, let's just copy and paste our 19 health variables. Control copy. Let's see, is that all of them? Yep, because the sex variable we already did. So jump back over to R and just paste that in. And now if we did it incorrectly, we would probably get an error message. But it looks like all of this is just code, like a big block of code. I don't see any errors. So now let's check the structure of CG17PE. Oh, I can't type. I put CH. I meant CG17PE. And now we have all of our health variables are recognized as factors, and we've set their. That's interesting. So this has 2's. Oh, I see what it is. So all of these are set to factors with the levels as indicated here, 0s and 1s, and these are the original responses. So it just keeps that there as well. I wonder if Glimpse shows the recoded values CG17 rather than retaining the original responses. Yeah, so if we look at glimpse, let me expand this and just call that command one more time. If we glimpse our data file, we can see everything is recoded as zeros and ones. Our sex variable is M's and F's, and yep, it's all indicated as factors. We still retain our weighting variables, which we didn't do anything with today. So that's good. We've successfully recoded our variables, and we've subset our data file to match the health indicators outlined in the surveillance summary. That's most of the cleaning that we'll do, but I want to show you one thing. So now we have the subset data file. We can export CG17PE, CG17PE.csv. We can export it if we want to save it. And let's open that back up from our R for BRFSS folder. So here it is, CG17PE. And we can see that we have all 23 of our variables, and everything is recoded, and we have all of our observations retained as well. But what I have been ignoring anytime I open up a CSV file, I'm sure you've seen it, but I didn't say anything about it, is this possible data loss. So when you export your data frame out of R as a CSV file, it keeps the numbers, everything is there. But what it forgets in that transition is now if we read that CSV file back into R, it will forget the character class. So let's call this let's just call this data frame X. So read.csv cg17pe.csv. Header equals true. Now if we look at the structure of X, all of the data is coded correctly, but it forgets that it's a factor, and now it's reading it as integers. It actually recognizes MF as a factor, I guess because male-female is a really common way of setting a factor, so R just it just knows that MF is probably a factor. But with these numbers, it still assumes it's integers. So if you want to save your data file, that's fine, but when you re-import it back in, you're going to have to reset your character classes. So that's everything that I wanted to show you for this first part of our three-part video series on prevalence estimates. I'm not going to close out R right now because I want to keep working with this CG17PE data file that has all of the correctly coded data and the correctly identified character classes. So I don't want to have to go back in and recode the character classes as factors. So I'm not going to exit out. I'm just going to end the video here and then start the next video on the data analysis. So when you come back, this is where we'll be, all right? Let me just go ahead and end now then. All right, thanks. I will see you very, very soon. Bye.